Hi guys, it's May 12th and today we are learning Chapter 11-3 Polygons. I'm hoping that you watched the video that I posted before watching these notes. If not, please watch that video and then move on to the notes. To refresh our memory, polygon is a two-dimensional shape formed with three or more straight sides. The examples below are regular polygons, and regular polygons are polygons that have all sides and angles that are congruent or that have the same measure. Today we will be learning on how to find the sum of the degrees of measures in the entire polygon, and then how to find the degree of each individual angle inside a regular polygon. Okay, in order to do that, we need to know the definition of a diagonal. Diagonal is a line segment that joins two non-consecutive vertices in a polygon. Now, non-consecutive means does not come one after another. So in this example, I'm going to tell you, let's take a look at the equilateral triangle. Okay, in the equilateral triangle, we have three vertices, and all of them are consecutive. They come one after another. However, in the square, we do have a non-consecutive vertices. So what you're gonna do is, you're just gonna pick one vertex and draw a diagonal, right? That creates two triangles. Now remember, this is a non-consecutive vertex. And then this one and this one are consecutive. Okay, so in the equilateral triangle, we know that the measure of one angle, and I'm going to use green. The measure of one angle, or actually the degree measure of the entire triangle, right? So we have one triangle, and the sum of all angles on the triangle is 180 degrees, right? Now, in the square, the sum of all angles in a square is 360 degrees. And how do we know this? Well, we know this because if I draw a diagonal like I did, it splits the square into two triangles, right? So this triangle is going to be 180 degrees, right? And this one, and if you add them together, it will be 360. So we have how many triangles? We have, actually, let's do this. We have two triangles, right? And the measure of the sum of measures of all angles is 360 degrees. Moving on to the next shape, and I'm just going to do a few. Actually, I'm going to do all of them really quickly. Again, these are regular polygons. So I'm going to choose any vertex. I don't know. I'm just going to choose this one right here. And again, I'm going to draw a diagonal from that vertex to every other non-consecutive vertex, okay? So that split this shape into three triangles, right? 1, 2, and 3. So 3 triangles, or 3 times, right, 180. 3 triangles, that would be 540 degrees. 540 degrees. Okay, so moving on to hexagon. Again, just wanted to know, let you know, right? Hexagon, it has 6 sides. So I'm just going to write that down. 6 sides. And again, I'm going to choose a vertex. I'm going to choose this vertex right here, and then draw down diagonals to each non-consecutive vertex, and that's splitting this into 1, 2, 3, 4 triangles, right? So again, polygon with 6 sides splits into 4 triangles, and we know that the measure of each is 180. So So we have 4 triangles, and the measure of the whole sum of the shape of the degree is 720 degrees. 720 degrees. Moving on to heptagon, and heptagon has 7 sides. So 7 sides. This one 3 sides. This is 4. Pentagon is 5, 6, 7. And again, choose a vertex, any vertex. So I'm just going to choose this one. I'm going to choose different vertices each time. And as you see, I'm splitting this into how many triangles? 1, 2, 3, 4, and 5. Okay, and I need you to start paying attention to the relationship between the number of sides and number of triangles that each shape can be split into. Okay, so we have 5 triangles. Oops. 5 triangles, and 180 times 5 will be 900 degrees. Okay, moving on to octagon. That's 8 sides, right? 8 sides. Again, I'm just gonna choose a vertex and draw the diagonals to every single non-consecutive vertex. Okay, and that would be 1, 2, 3, 4, 5, 6. So again, we have 6 triangles. 6 triangles, and that would be 1080 degrees. 1080 degrees. Moving on to the last 3, we have nonagon. Nonagon has 9 sides. We have decagon that has 10 sides, and then I just gave you the decagon. The decagon has 12 sides. Okay, I kind of skipped 11, which is fine. Okay, so in the nonagon, again, same thing. We have 1, 2, 3, 4, 5, and 6. We have 6 diagonals. 1, 2, 3, 4, 5, 6, 7 triangles. And in a nonagon, we have 7 triangles. And let's see, and the degree of 7 triangles is 1260 degrees. And let's see, and decagon, we have 10 sides. 10 sides, that means right away I can tell based on the relationship from the previous polygons that it will have 8 triangles. So let me see, 1, 2, 3, 4, 5, 6, 7 diagonals, and 1, 2, 3, 4, 5, 6, 7, 8. I was right. So it's 2 less. Did you notice that it's 2 less triangles than sides? So each polygon, notice, when we are splitting this into triangles, each polygon, right, the number of triangles is 2 less than the number of sides. So decagon, we will have 8 triangles. 8 triangles in the decagon, and it's 1440 degrees. Okay, so we will have, let's see, 10 times 180. Here we go. Okay, so moving on to our last one, there's 12 sides, the decagon, and let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have, let's see, oh my gosh, did I skip one? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, that means it's going to form 10 triangles, and 10 times 180 is 1800 degrees. Is that correct? So 180 times 10, right? Okay. So did we notice that relationship between the number of sides, and number of triangles formed is 2 less. So that brings us to our formula on how to find the sum of all the degrees. I'm going to scoot this up a little bit. Okay, so the formula says, I'm going to do, I don't know, how about green? Basically, since the relationship is number of sides 2 less, number of the triangles is 2 less than number of sides, so I'm going to put n, the sum of the degree measures of the interior angles with n sides is found by subtracting 2 from the number of sides and multiplying it by 180 degrees. Okay, just like what I did, right? So the number of sides minus 2 will give you the number of the triangles it forms times 180, and that's what I did. Okay, so we will just have one example really quickly. One example here. I'm going to ask you first to find the sum of the interior of all interior angles in a tridecagon, which is a polygon with 13 sides, tridecagon. And then I will show you how to find the measure of each angle. So as we know, the formula says number of sides minus 2 times 180 degrees will help us find the sum of all interior angles in a polygon, in a regular polygon. Okay, so let's take a look. Number of sides is 13. 13 minus 2. 13 minus 2 times 180. Now 13 minus 2 is 11, and 11 times 180 will be 1980 degrees. This is a sum of all interior angles in a regular polygon, in this case tridecagon. Okay, so now how would I find the measure of each angle? Remember, in the regular polygon, each angle has the same measure, so that would be easier to find, right? So let's take a look. What I'm gonna do, because I have 13 sides in this polygon, that means I will have 13 angles. So I'm gonna take the sum of all angles, which is 1980 degrees, 1980 degrees, and I'm going to divide it by 13 sides or 13 angles, and my answer will be 152.3 degrees, and this is each angle, degree of each angle. Now please be careful what it says to round it to, so in this case I'm just going to round it to the nearest tenth. And again, we're using calculators to find this. So again, this is it on polygons. Super easy. Make sure you do all the practice, and I will see you tomorrow for the next lesson. Good luck. Mrs. Boone.